I had a question about taking the derivative of this function, and it was part of an application problem, but we're just going to focus on taking the derivative. So to find b prime of t, you're going to take the derivative of 30, and then the derivative of this 15t squared all over t plus 3 squared. Okay, now right here, the derivative of 30, I mean, that's super simple. But the derivative of 15t squared divided by t plus 3 squared is a quotient rule, okay? The quotient rule says to write down the denominator, multiply it by the derivative of the numerator, and then minus the original numerator times the derivative of the denominator all over the denominator squared. So in doing that, the original denominator was t plus 3 squared. And when you multiply that by the derivative of the numerator, let's see, the derivative of the numerator is 30t. And then moving right along, it says to take, just to write the original numerator down, so 15t squared, and multiply it by the derivative of this denominator right here. Okay, well, that derivative is a chain rule. Okay, so basically this problem, you had a quotient rule, and within that quotient rule you had a chain rule in the denominator. So imagine that t plus 3 squared as a u squared. Well, you would say 2u to the first power, okay? And I don't really refer to this as u substitution a lot, so I'm going to erase that u. I'm just going to write down the inside t plus 3. And remember, it's to the first power, but in the chain rule, you also have to multiply by the derivative of the inside of what I highlighted right there. The derivative of the inside, which in this case is just 1, okay? And that whole thing is over the denominator squared. So cleaning this up a bit, I got rid of the 0. I didn't bring it down. And now that I've cleaned it up, I see that we have a GCF, let's see, and first of all, I do want to clarify, I did not distribute the 30t right here to that binomial of t plus 3 squared because the binomial was raised to a power. It was squared, so I can't distribute something to something that's not simplified. So if I wanted to distribute that 30t up there, I would have to FOIL that binomial out, the t plus 3 squared. I would have to say t plus 3 times t plus 3. I don't find that useful because I saw that t plus 3 is really a GCF because it happens in both parts. Okay, so I can take out a t plus 3 to the first power. I could also take out a 30t as a GCF, and what I would be left with, okay, so I took out 30t. So that's 1. I don't really need to write that 1 there. But if I said t plus 3 squared divided by t plus 3 to the first, I'm just left with t plus 3 to the first power minus, okay, the t plus 3 over here cancels with the 1 in the GCF. And then I say, well, 30 divided by 30 is 1. But t squared divided by t in the GCF leaves me with t. Okay, so now I'm looking like this. Which, okay, follow this. This first power right here and this fourth power cancel to give me t plus 3 cubed, and I no longer have the 1 in the top. And so now I have 30t, and I'm going to distribute up here. Well, actually, there's no need to distribute at 1. You have t plus 3 minus t, which is just 3, okay? And so that ends up giving you just 90 t over t plus 3.